So far, we talked on this podcast about beer, about fashion, packaging, food ingredients, and events. These are all industries with brands that most people will recognize, or at least emissions that we can roughly picture, such as a farm, a factory, a shipping container, or a festival. So what's next? What are we talking about today?
Yeah. Well, today's industry has none of that, right? It doesn't have a consumer face, it does not have a brand on a shelf, and you've probably never heard of most of the large companies in it. Yet there is a good chance that their output is in the cup that you're drinking out of right now. It's in the chair that you're sitting on. It's on the shoes that's on your feet. It's on the coating of the floor of the room that you're in right now. Because it's 6% of global CO2 emissions. It's upstream of almost everything that we've covered so far, but it's mostly absent from the sustainability conversation.
Right. Today let's talk about ethylene, polyurethanes, polycarbonates. If you ask me, the most sexy words in the dictionary.
Yeah, so today we're talking about chemicals.
Right. Maybe before getting into the weeds, I think chemicals is a bit of an enormous word because I think pharmaceuticals, polymers, fertilizers, solvents, pigments, they're all chemicals basically.
Yeah.
So where do we start with this from an emissions perspective?
Yeah, so there's mainly three places, roughly. The first is energy. So running chemical plants requires enormous amounts of heat. We're talking 800 to 900 degrees Celsius in some of the processes. Right now, that heat comes from burning fossil fuels, which is a lot. And then the second is feedstock. Most chemicals are made from oil and gas, and the carbon in the molecule is the product, right? So you're not burning it, but you're turning it into plastic or fertilizer or foam insulation even. But it still has to come from somewhere. Then the third is process emissions. So some chemical reactions just release CO2 as a byproduct. Since now that we've gone through the hotspots a little bit, but I kind of want to turn the question to you. Who are we actually talking about? What does the company landscape look like?
Right. So the chemical industry definitely has a few giants. BASF is the largest chemical company in the world. Their main site is in Ludwigshafen in Germany, and it's so large that it has its own power plant, its own harbor, even its own fire brigade. And their yearly emissions total around 20 million tons of CO2 equivalents, which is more than some countries.
Exactly, it's definitely more than some.
Yeah, and then next to BASF, there's Dow, SABIC, LyondellBasell, which are all roughly in the same weight class. So SABIC is majority owned by the Saudi company Aramco, which is the world's largest oil company, which faces significant controversies surrounding, obviously, its massive environmental footprint, but also sports washing to improve its image, as well as human rights concerns.
Yeah.
So all of this makes the sustainability optics a little bit complicated.
Yeah, to put it mildly, I would say.
Exactly. And I think what makes chemicals genuinely different from most heavy industries is that the emissions problem doesn't stop at the factory gate. So when a chemical company sells you plastic, that plastic will eventually be incinerated. And so the carbon in the original feedstock ends up in the atmosphere, but a lot later, somewhere else, and probably counted as someone else's emissions.
Okay, so the company that made it doesn't really carry it.
Yeah, most of the time not under current carbon accounting. So you can clean up production entirely and still have a carbon tail that follows your product for decades. So that's the reason why this sector can't just be about operational efficiency. The feedstock itself has to change as well.
Which I'm assuming is a fundamentally harder problem than just switching to renewables, right?
Exactly. Unfortunately, much harder. Because the molecule is literally the business. And so, given all of that, maybe back to you, Senna, what are some real reduction levers? What actually moves the number?
Yeah. So I would say there's about four of different reduction levers. The first one is the electric crackers. So the steam cracking process that I mentioned before, the heating of the hydrocarbons to 850 degrees to make plastics. Right now, that heat comes from burning gas. The idea is to replace the furnace with electric heating powered renewables. So that technology, when you think about it, does exist. There are pilots that are running. So BASF, Dow, SABIC, like you mentioned before, they have been working on this together. The bottleneck right now is the European power grid, which isn't stable or cheap enough yet to run industrial furnaces around the clock.
Okay, but so it isn't really a technology problem.
Yeah, exactly. The technology is ready. It's just the energy market that's not ready. The second lever is green hydrogen. So, a big chunk of the chemical emissions comes not from plastics but from fertilizers. So, making ammonia, the basis of most synthetic fertilizers, requires hydrogen. Today, that hydrogen comes from natural gas, which releases the CO2. When we say green hydrogen, it uses renewable electricity to split the water instead. So essentially, it's the same molecule, but it has no fossil input. So companies like Yara and Ørsted have been working on this together, which is great. And the process does work. It's just more expensive than the fossil version, unfortunately. And without a carbon price, that gap doesn't really close on its own.
Okay, so you mentioned electric crackers and green hydrogen. What are the other
Yeah.
two production levers?
Yeah. So the third is the bio-based feedstocks. Instead of starting from oil, you start from a plant material or captured CO2, right? So the molecule that you end up with can be chemically identical. A plastic is a plastic, but the carbon came from last season's crops, not a well that's sealed for 300 million years. So it doesn't really solve everything, but it does break the fossil dependency at the source, which is good. Then the fourth one is the one that I like the most, which is chemical recycling. It's completely different from what you do at home. So mechanical recycling grinds down the plastic down and it just remolds it. But by doing this, you degrade the quality really quick. Chemical recycling breaks the plastic all the way back down to its original building blocks so that those monomers can make virgin quality material again. It's expensive, it's not yet at scale, but it's the only version of recycling that actually closes the loop.
Right, so fully circular. So I think
Yeah.
maybe in summary, so you mentioned the electric crackers, green hydrogen, bio-based feedstocks, and lastly, chemical recycling. But it does sound like all four solutions need some kind of economic push to get adopted at scale.
Every single one needs either a carbon price, a subsidy, or a customer willing to pay a premium for a low carbon version.
Here's a number that actually should bother us. Roughly half of the world's largest chemical companies currently have no validated SBTI targets.
Half is a lot for this industry.
Yeah, and of the ones that do have validated SBTI targets, almost none have a scope 3 pathway that goes beyond kind of vague language about supporting customers in their transitions. Because in contrast to industries that we talked about in previous episodes, for a chemical company, scope 3 is largely downstream. So it's the brands, the manufacturers, the packaging companies who buy the polymers, etc. So it's very easy to talk about, but it is in nature very hard to commit to downstream action.
Okay. Which, from what I understand, it means any sustainability manager that's working on scope 3 category 1, which is the purchase goods, who's buying the chemicals, is kind of completely dependent on these suppliers to publish credible data, but most don't.
Yes, maybe I think it's also important to highlight some positive stories and examples. I think BASF is a bit of an exception. They actually publish product level carbon footprints for most of their catalog. So these
Okay.
are real numbers, third party assured, based on their actual Verbund production process. It's not perfect, but it leaps ahead of the chemical industry average. It is actually a good example of a player that's building transparency infrastructure that everyone downstream benefits from.
Okay, well, that's cool. It's nice to hear these positive examples. And is there anyone that's doing something that's kind of like structurally different?
Yeah, I mean, maybe a second very positive example is Covestro. Bit of a different angle, but equally concrete. So they make polyurethanes and polycarbonates, which are historically both fossil-based. Their bet is now on CO2-based chemistry. So they are replacing some of the fossil naphtha with captured CO2 as a raw material. This product is called Cardian, but they've already been running this commercially since 2016, so a decade ago.
Yeah.
So it's really no longer a pilot. It's something that is really already fully rolled out, and it actually cuts fossil feedstock used in that line up to 20%. And, which I think is very hopeful, they have committed to fully circular feedstock by 2035, meaning that their feedstock will either be recycled material or biomass or captured CO2. So that is a structural shift in business model and not just an offset play.
Yeah, that makes me excited. It's good to see that there are blueprints that exist.
The blueprints do exist. Unfortunately, most of the industry is still citing grid constraints and commodity prices as reasons to wait.
Okay, well, now that we've kind of went through the hotspots, the reduction levers, which companies are doing what, where do we land? Where does all this land?
So I think, in conclusion, the chemical industry is really the invisible backbone of almost every other industry's Scope 3 problem. So you cannot decarbonize food packaging, automotive parts, construction materials, or textiles without touching chemicals. It is upstream of, basically everything else.
Yeah, and like I said, the levers do exist. The electric crackers, green hydrogen, the bio-based feedstocks, the chemical recycling, none of them are science fiction. They're just engineering problems with known solutions but unclear economics.
Right. So what's missing isn't technology, it's carbon pricing that's serious enough to change procurement decisions. It's really customers' willingness to pay for low carbon chemicals and the suppliers being able to provide verified real data.
And I think that's why Scope 3 data from chemical suppliers matters so much, right? The brands buying petrochemicals to make your shampoo bottle, they don't have an idea of what the footprint of that input is because most of them don't ask and most suppliers, they can't answer.
Yeah. So I think, to maybe end on a hopeful note, the molecule problem is solvable. It is just going to require the chemical industry to take accountability for where its molecules ends up and the rest of the supply chain to start demanding it.